Hi everyone, so let's talk about find a city with the smallest number of neighbors at a threshold distance. So in this video, I'm going to talk about the Bellman rule, right? So if you haven't watched this video, please spend like 17 minutes to finish this video, and then you'll probably have a better idea of what I'm doing, right? So what is this? So Bellman rule is basically pretty straightforward. So imagine that you have a weight, right? But you set everything to infinite at the beginning, except the first one. This one should be a 0, right? Okay. Now you need to keep traversing your 2D array edges, right? And then keep updating. So 0 to 1, you have 3, so you get rid of this. So this becomes 3. And then 1 to 1, so 1 to 1, and then the edge is 1, right? But the current value is 3, so 3 plus 1 is actually 4, right? And what else? 1 to 3, 1 to 3, right? 3 plus 4 is actually 7, right? So and let me just update to 7. And then 2 to 3, 2 to 3, 2 to 3. So 2 to 3 is what? 4 plus 1 equal to 5, right? So since you updated, right, you need to keep double checking that if there is a better way that you can go from one to another, right? So 0 to 1 is 3, 0 to 1 is 3, so this doesn't change. 1 to 1, 1 to 1, okay, this doesn't change, right? So 1, 3, 1, 3, 4, right? 1, 3 is actually 4, so I can actually go this way, right? 1 plus 1 is actually 2, but plus 3 is, which is 5. So this get updated to 5, right? And then 2 to 3, 2 to 3 is 5, right? All right. So this is, I mean, after you traverse the entire n minus 1 time, so you have to traverse at most n minus 1 time, right? And then you will get a final edges minimum value for every single edge, and this is pretty much it, right? So this is going to be similar. You need to create a list of array for the adjacent city, and then basically this is pretty much like Dextra, right? So I upload a video for Dextra solution, and Dextra solution is a little bit just a little bit complicated to write, but this is going to be a similar stuff. So I have a list. I'm going to pass it in array, right? And this is has to be a array of list, right? And I'm going to call new list, and I give it a set button, right? And then for every single one, I need to initialize, right? So adjacent at I equal to new array list. All right, so I pass in the in array. This is because I want to give the destination, location, and the cost, which is weight, right? Now I need to what? I need to set an infinite at for my value, right? 7 plus 7. Now I need to 2D. Yes, I need 2D array. Given the size by n by n. So if you remember that I draw the diagram, this is based on the 2D array. Like I store the value, I keep updating my value in my 2D array, right? Now I need to initialize my 2D array to infinite at first. So the array shall fail. This at I equal to infinite, right? And just for making sure, like if you want to traverse from city 1 to city 1, right? So which is from your location to your location, which is cost of what? Cost of 0, right? You don't spend any weight on it, right? And now I need to traverse the entire weight. Sorry, entire edges, right? And this should be array. So this should be what? U equal to edges 0, V equal to edges 1, and then weight equal to edges 2. So I need to add everything into my adjacent, right? So I'm going to say abj u dot add new int v comma weight, right? And this is going to be similar for the adjv, and then this is going to be u, right? This is bidirectional, right? Okay, now I need to what? I need to traverse the entire point, right? So I'm going to say from every single point, you need to keep doing this until everything is satisfied, right? So this is going to be about Bellman. I'm going to pass in the Bellman function, and I'm going to pass in n. I'm passing ages, and I also need to pass in a dSi and current position, right? So public Bellman in n into d, right? Ages into d this only 1d only, and then in source, right? So you might confuse why I only need 1d. This is because I can only pass. I only need the current rule for the 2D array. All right. So let's talk about how I do it. So I need to I need to traverse from 1 to n, right? So I started from the I equal to 0, right? And then for every single time I need to traverse every other point from CD1 to CDN minus 1, and then I need to traverse the edges, right? Then I'm gonna say u equal to edges 0, v equal to edges 1, and then weight equal to edges 2. Okay, so for every single time you store your current value inside the disk, right? So you only take the current rule for the disk, and if you say disk 0, right, you will take the 2D array disk rule. So here is it. You are given 2D array for this, right? So this is 1 0 1 2 3. So if I say disk 0, right, you grab this one. If I say this one, if I say this one, you grab this one. So you don't need 2D array inside my helper function. So since I'm keep updating, so if I this at u, it's actually greater than what? It's actually than this at v plus the weight. Since it's bidirectional, right, you can actually keep updating. This of v plus weight. And exactly going to be the same thing for this of v. If that is greater than this of u plus v, right? And then you can just keep updating your this of u plus v, right? So this is pretty straightforward. So if you don't understand, which means you have to finish this video. So if I want to talk about what is Bellman for, right? I will have to spend more than 17 minutes because this is professor and not professor, and when I explain it, you might get confused, right? So this is just better if you finish this video and come back for the solution. And here's it. So now after I finish the Bellman, right? Bellman function, I need to return the minimum CD, right? Return the CD with the smallest number of the CD that are reachable through some path, right? So I will have to traverse the entire CD. But the problem is what? I store every value inside my disk, right? And if I equal to j, right, I don't want to bother, right? And I also need a current CD count, right? And this is going to be min CD count equals 0, and I also need my return value for min CD. I'll say equal to -1 first, and at the end I'll return min CD. Alright, so for every single time I need to keep track of what threshold, right? Distance threshold. So if this is ij, which is less than equal to distance threshold, right? Well, let me copy and paste. If that is true, I'm going to just keep increment my CD count, which is like which is like you are allowed to traverse from the CDI to CDJ, and then how many CD, number of current CD, right? So after the for loop, I will know for the first one how many CD I can traverse, 2, right? So I will say if the min CD count should be starting from n. This is because we have to minimize, right? So sorry about the mistake. So the min CD count, if this is if this is greater than the current CD count, I will have to update my min cd count to current cd count, right? And I set my min cd equal to I. This is because if you have if you have an index, then you can just return, right? So in this case, 0 and 3 are 2 cd, but you have to return 3. And so this is because you need to have equal sign right here, right? So 3 will get replaced for the cd is 0. And this is pretty much it. So let me submit. So I do have a development void, right? Okay, cdij less than equal to distance. All right, I found out a mistake. So I forgot this. This should be j. Sorry about this. And yeah, here we go. All right, so let's talk about time and space. So normally the Bellman force time and space complexity. This is definitely on Google for sure. It's based on the edges and vertices, right? And then it's gonna be what this is what all of n times the Bellman function. Bellman function is what all of n times the edges. So it's gonna be n squared times the number of edges, right? And but for my solution, this is gonna be what this is all of e. E represent length of the edges. This is all of n. But inside this you have fill, right? So it's gonna be all of n squared. And I would say for my time and space, it's gonna be n squared times e. So n squared times e, and then space is all of n squared, right? And this is the solution. And I'll see you next time. Bye.